Right, in this example, what we're going to try and do is solve these equations by inspection. Inspection just means we're going to look at it. So what we're going to do is we're going to put this in a graphing calculator, and we're going to look and we're going to see where the solutions, the zeros, are, and we might have an assist from our calculator's ability to calculate zeros. So first thing we're going to do is, for problem A, let's go ahead and just throw that into our calculator. So we go to the y equals screen, and notice this is very important that one side equals 0. Unless one side of the equation equals 0, we can't do what we're about to do. But this over here is equal to a 0, so I'm going to assume that for purposes of this, that's my y. And so I'm just going to put in here x squared plus 9x plus 14. And I hit graph, and I can see that this will have two solutions because it has two x-intercepts right there and right there. Now I just need to calculate those. And I will go ahead and use the handy-dandy features on the calculator. You'll notice in blue it says calc, which stands for calculations. So I'm going to hit the second button and go to that calculate menu, and I want to calculate zeros, which is another name for an x-intercept. Now, this is the hard part. It's going to ask me for the left bound. And you can see I have this little cursor that's moving along there. Left bound means that cursor needs to be on the left side of whatever zero I'm trying to find. I want to find this zero right now, and so my cursor needs to be to the left of that. So I put it there and I hit enter. Now it's asking me for right bound. So I take my cursor and I put it on the right side of the zero, making sure that I don't interact with this other zero at all, staying well away from it. Press enter, it'll ask me for a guess. You can make a guess if you want to, but really you can just hit enter and it'll tell you that one of the zeros is x equals -7. So there's actually two ways of writing this. I'm going to write them both so that you can see them. I can write that as x equals -7, or I can write that as an ordered pair, which would be -7, 0. Both of those mean exactly the same thing. They're just two different ways of writing that solution. Now, as I said, this has two zeros, so I need to go calculate the other one. It's asking me for the left bound, so I'm going to make sure my cursor is on the left side of this zero. My right bound, my guess, and it's telling me that the zero is at -2. And so I can write my other solution, x equals -2, which would also be -2, 0. So that's my answer right there. Those are my solutions, that right there or that right there. If you're answering on a test, really you only have to give one or the other. I just want to write both here so that you recognize they're both solutions. And now we're off and running on this thing. So let's go ahead and tackle this next one kind of quickly. It says 6v squared plus 48v plus 96, but hold up, I don't have a v on here. That's okay. Just use x instead, and know that when you see an x, we really mean v. Plus 48x, which is like our v, plus 96. And when we graph this thing, this comes out to be kind of a unique situation. This just touches the x-axis, which means it's only going to have one solution. So when I calculate my zeros, I only have to do that once. And just as before, I'm going to take my cursor, and I'm going to put it first on the left, then on the right, and it will tell me that my 1, 0 is, and I'm glad it did this. Notice it says -3.99999. The calculator is approximating this. It's not getting an exact value through algebra. It's doing just a lot of computations to come up with something about this. So when you see -3.99999, you're very safe in assuming that that is actually 4. So the solution here would be x equals -4, which we could also write as -4, 0. And because it just touches the x-axis in one place, that's our only solution. So that's our answer right there. Now, for part C, there's something else going on here we need to take a look at. Part C, you'll recall that I said this has to be equal to 0 on one side before we can do anything with it. Part C is not equal to 0. Neither side of this equation is a 0, so we need to make one side or the other 0. This side has less stuff on it, so it would be a good candidate to make equal to 0. So to get rid of that -4, what I'm going to do is add 4 on that side. That will add together to give me 0. But if I did it on one side, I have to do it on the other. So this leaves me with 12x squared minus 6x plus 4 equals 0. Now I'm ready to throw that in my calculator and see what happens. So we'll go to our y equals screen. We're going to have 12x squared minus 6x. And we're adding to that 4. So now we press the graph button and we see what it spits out. And notice this does not cross the x-axis at all. It's way up here and it never actually interacts with the x-axis. So there's no more looking to be done here. Since this doesn't cross the x-axis, it doesn't have any x-intercepts, there is no real solution to this problem. Now, notice that that doesn't mean there's not any solution ever. It means there's no real solution. We will have what we call imaginary solutions. We're not going to go down that rabbit hole just yet. Alright, so there is how you can solve these quadratic equations by inspection.